Welcome back, everyone. This is the final chapter of Simplifying Radicals. In this section, we're going to go over a really good bonus type problem. So this problem is talking about if we have radicals being multiplied by each other that don't have the same index. Okay, so let's look at this, the theory behind it. Here we have a to some power, and notice how k is a factor of both kn and km. Okay, so that's important to know that k is a factor of both of these. Sorry, those colors didn't mesh very well. So what that means is essentially we are going to cancel out those k's. So we're going to be left with a to the m and the nth root of that. Essentially the k's are going to cancel out because they're both factors, okay? So let me show you how that plays out. So if we do have something like the square root of 7 times the cubed root of 2, our first step is going to convert radical to a power, okay, to an exponential power. So in that, I'll write in parentheses rational exponent. So think fractions. All right, so let's go ahead and do that with both. So if we were to write square root of 7 as an exponent, that would be 7 to the 1/2 power times, and now we're going to write 2, and this becomes 1/3 power. Okay, so we're done with step 1. And then step 2 is convert exponents of both to have a common denominator. Okay, so common denominator. So here we have 1/2 and 1/3. So we have to have these have the same denominator, okay? We want them to have the same factor. Notice how these are both the same factor. Well, we want that same factor to be with both of these, okay? So what we need to do is off to the side, we need to think, okay, 1/2, 1/3, how do we convert these to have the same denominator? Well, the common denominator is going to be 6. So I know I'm going to put both of these over 6. I multiply 2 by 3 to get 6, so I need to do 3 times 1, give me 3. 3 times 2 gives me 6, so I need to do 3 times 1 times 2 to give me 2. And now I have my new exponent. So I'm going to write, instead of 7 and 1/2, I'm going to write 7 and 3/6. Instead of 2 and 1/3, excuse me, 2 to the 1/3 power, I'm going to write 2 to the 2/6 power. Now, why is this useful? It still looks like we can't do anything. The whole point was to get these roots, okay, this denominator in the power. Because what we can do is, this is one of our rules of exponents, is we can take that power out and put it outside the parentheses and leave these guys by themselves inside the parentheses. Let me change this to pink. Sorry, that's bugging me a little bit. So 7 cubed times 2 squared. Why does this work? Well, if I essentially distribute this power to both, I'm going to end up with these here, which is the same thing as what we started with, which is this, okay? So I can do that. That's within the rules of mathematics, okay? But now I have a much easier problem. Now I can actually combine them, where before I couldn't do anything, okay? So essentially what this problem is it's the 6th root of 7 cubed, oh, I forgot the wrong color again, hold on. 7 cubed times 2 squared. Now this becomes a very simple problem because I just needed to simplify inside the radical. So I do 7 cubed times 4, and that gives me 1,372. Okay. Now, if you want, you can search for anytime we have 6 identical factors, 6 identical prime factors, or any factors for that matter. In this case, there aren't any, and this is your most simple answer. Okay. Let me show you how to do this one more time with one final example, and then we are done with this section. Okay, so here we have the cube root of 5 times the square root of 6. They don't have the same index. At first glance, it looks like you cannot simplify this any further, but you can. Just requires a little bit of manipulation. So 5 to the 1/3 power times 6 to the 1/2 power. Okay, so now what we need to do is we need to find a common denominator. This is very similar to the problem above, so we're just going to use the same conversions that we did, which is 2/6 and 3/6. Okay, 1/2 is the same thing as 3/2 or 3/6. Let me show you that these are equivalent and these are equivalent powers. Okay, but now they have a common denominator, so what we can do, 5 squared times 6 cubed, and we are taking out the 1/6 power. So now what we can do is we can do the 6th root of 5 squared times 6 cubed. What that becomes, it becomes the 6th root of 5,400. Now there's no factor that appears 6 times that's identical, so our final answer becomes just that. Hope you guys enjoyed this section. The whole point of this is to give you a few tools that helps you solve these problems. I don't expect you guys to watch these videos in its entirety. Hope you guys fast forward, pause, rewind. It's for you guys and for your learning, so use them as you wish, and I hope you have a wonderful rest of your day. See you next time.